Welcome to Equa. In the following, we will show you how you can specify your own custom controls in IDA ICE. These are the custom controls we will introduce you to. These are examples for controls that are not available in IDA ICE, but the software gives you the option to specify them yourself if you need them. There are, however, also a large number of pre-specified control strategies already available to the user. Here we list you some examples of pre-specified controls as well as custom controls you may want to define yourself. For the latter, the software gives you complete freedom and flexibility, and you can define almost any scenario. Before we look at how you specify your own controls, let's look first at an example of a pre-specified control. For instance, in this window form, we can specify a shading element for the window, as well as its control strategy. Every control strategy comprises of a control regime, in this case the solar intensity. A schedule can in addition adapt the control signals over time, for instance limiting it to certain periods. The threshold for the solar intensity is defined as a system parameter. The user can also specify whether the solar radiation should be measured on the facade or behind the glazing. Now this was a pre-specified control. Let's look at how we can specify our own custom controls through a control macro. For this, we select the option New Custom Control. We call it Zone Air Temperatures. For the definition of the control, you have different objects available. Some of them are already contained in the macro itself. The object zone, for instance, measures different variables in the zone. And setPoints contains a setpoint collection for the zone. Then we also have the radiation as a signal, as well as the previously mentioned schedule as a second signal. On the right-hand side is the output signal, one for the opening and closing of the shading element, and one for the tilt angle of the slats of a blind. Then we can also incorporate additional objects from the palette on the left. Under Control, we find different control objects, such as proportional, PI, or on-off controllers, tools to find maximum values or minimum values, or a comparator and a sequencer. Under Utility, we also find a series of useful objects. Examples are zone sensors to determine conditions in one or a number of zones, or schedules and source files to provide time-dependent signals. Under Links, we find a series of objects that are used for advanced controls that pass on signals between different hierarchical levels. For instance, from the central building control to the zone level, and from there to the control of objects that are contained in this zone. These advanced controls are not covered in this movie. For our first example of a custom control, we position the PI controller in the macro and connect it to the zone object. We also specify the air temperature in the zone as a signal for the PI controller. As the next step, we need to specify the setpoint for the controller. We do this by including a constant object through which we specify the setpoint. We could also have referred to the setpoint collection of the zone. Lastly, we connect the out signal from the controller to the shading signal created by the macro, which is then passed on to the object the macro controls. After that, we need to specify that the controller should operate in cooling mode, specified through the setting 1, which means that the controller gets active when the measuring signal gets close to or above the setpoint. To check our control, we utilize the very powerful option of logging variables to an output file. Let's create a second macro. This time, we want to control the shading object with respect to the lux levels in the space. Again, we start off with the PI controller. However, since the predefined object zone does not provide the lux levels, we need to measure this through a zone sensor, an object that can determine a large number of state variables in the zone. With each zone sensor, the user has the option to define in which zone or zones a variable should be measured. Again, we define the setpoint and that the output from the PI controller should be the out signal of the macro, and that the PI controller operates in cooling mode. And once more, we monitor the control signal. Here we see the first control in operation. The blinds are closing whenever the internal temperature reaches 23 degrees C. We can also interrogate the results in more detail, as we do it here with the outcome from the second control macro. At the top left, we see the lux levels in a zone without the control macro. At the top right, for an identical zone with the control macro. At the bottom, we see the control signal that was created by the macro. We see that the control maintains a maximum lux level of 600 lux. The signal has a maximum value of around 0.5, which means that the blinds are half closed. The next days are sunnier and the signal increases. Let's build another control. This time we want the conditioning of a room to be switched off when it is not occupied. Here we see the occupancy schedule of the space. In the control macro, we have first specified the basic heating and cooling control. Then we incorporate a check if the zone is actually occupied and ensure that heating and cooling is only switched on in these periods. This is done with an AND object which receives an input signal from the PI controller but also from the zone object to signal if the zone is occupied or not. These are some results. The top left graph shows a zone that can be continuously cooled. The graph on the top right applies the control we just defined. The rooms are west facing, hence there is a cooling demand in the afternoon. However, for the second room, the cooling only turns on once the space is occupied. Let's look next at how we can create our own lighting control that also takes into account whether an occupant is present in the zone. Here we see the occupancy schedule. This is the still empty control macro. It is structured very similar to the previous macro, but this time it creates an out signal for the light fitting. We include a zone sensor and a comparator. The set point for the light level is 500 lux. The comparator compares the lux levels in the space against this set point. An AND object checks whether artificial lighting is needed and if the space is occupied. It then creates a signal that is also the out signal of the macro. Here we see a display of the lux levels in the zone as well as the signal created for the artificial lighting. This is only turned on when the zone is occupied and the lux levels falls below the set point. Finally, we want to create our own control for an air handling unit. In the pre-configured air handling unit, there are three options for the definition of the supply airstream temperature: a constant value, through a schedule, or as a function of the ambient temperature. We now want to define the supply temperature as a function of the temperature in the zones. As the first step, we replace the ambient temperature signal with a zone sensor. Next, we specify that we want to determine the maximum temperature that occurs across all zones. After that, we specify the supply temperature that should be provided at different zone temperatures. The data can be entered via the keyboard, but also viewed and edited in graphical form. Here we see the air temperature in two identical reference zones. The zone on the left has an income airstream at constant temperature. For the zone on the right, the temperature of the supply airstream is adjusted with respect to the zone air temperature. We see that the temperature in the second zone is a lot more stable. Thank you for your interest in IDA and for watching this video. To find out more about our software, please visit our website.